This episode was brought to you by Pen Tester Academy, the leader in online cybersecurity education. Join over 10,000 professionals from 90 countries to learn security online. Also brought to you by Hacker Arsenal, artillery for cyber warriors. Visit us on hackerarsenal.com to check out our latest attack defense gadgets. I'm Marley Oxenholm from Pen Tester Academy TV, and welcome to our show, Access Point, where we spotlight cybersecurity companies and give an inside look at the people and technology behind the latest advancements in the industry. Today, I will be speaking with the company White Hawk Software. I'm sitting down right now with Chris Jacobi, who is going to show us a demo of protecting an application against dynamic differential attacks. Take it away.
I love to show this demo. Thank you very much.
Absolutely. Thank you for showing me.
You have certainly heard of the demo effect. Have you seen a demo where you first compile the application you want to demonstrate?
Cannot say I have, no.
So we'll do that. Let's hope it works.
Okay.
The other question is, have you seen demo of a security tool? You know, when the security works, nothing happens.
Very true.
This demo will show kind of an attack which is important for security companies and banks. Okay. I will show you the program we want to protect, which is now on the monitor. And this is not the real application. This is a demo application. However, it stands for something. And the important thing we're going to go protect is the inner loop, which I have now selected. When we see here, there are 2 for loops, and the whole thing shall be a placeholder for a decryption. The inner loop may be what in a cryptography program would be a checkbox, which is a short, loop-free selection of lots of different shifts. And I'll simulate this here with a little for loop.
Okay.
So, to protect against dynamic differential attacks, we have to make sure that the power is a little bit randomly disturbed, and that one cannot, from looking from the outside of the computer, go and reconstruct the keys. If you have heard from white box cryptography, that's an element of cryptography which is almost impossible to hack, but in reality it is very easy to hack. And what it needs to become secure is simply that what we're doing here, add some random noise.
Okay.
So we are taking this selected area here and want to create a clone of it. Then we will make sure that at runtime the clone and the original will be executed more or less the same time according to some random schedule. And since we also will obfuscate the application, the clone and the original will not have the same timing behavior. This is a typical protection which is high-end, because we could not automatically figure out what needs to be cloned.
Right.
In this particular case, we use these markers here. With these markers, you can tell my code a range.
Okay.
With these markers, you can tell my tool the range of code which needs to be protected. These markers will not have any runtime influence, because the protection tool recognizes the calls and will remove that code completely.
Okay.
So how can we write a script which will protect this particular area? And we see here a protection script. This can save as 2 things. This can save as a generic protection script, like you write protection script, but it also saves a script for this test program. and there are certain areas. I'm selecting this first paragraph. The main point is we have to tell the tool what file we want to protect, which is here. So this is all which is needed for the file. The interesting part, however, is the protection part. When we look at this paragraph, this is the whole protection. What we see afterwards, I'll explain what it is, but it's not part of the protection.
Okay.
We remember the markers A and B, which describe the range we will clone. So we tell the protection tool that it should do cloning here, and we also tell the protection tool that this clone is the clone named our clone. We'll use this later. So at this point we could do the protection. But as I said, a loop which does nothing and then showing that nothing happens is pretty boring. So we put some spice into this, and it's actually useful spice. I will put in here a proof that the cloning did work.
Okay.
And it's a very unusual protection because the protected program will not perform exactly like the unprotected protection. This proof is something which I would assume that the customers will not do, but the proof has been very useful for me to make sure that the protection really works.
Okay.
If we look what we're doing here, we're having an aspect like before. This is, however, a run trace aspect. A run trace aspect in our tool means we're tracing the application at runtime. Okay. If it wouldn't be a run trace, just a trace, it would trace the protection process. But we want the protection at runtime. We have to tell where that protection happens. So we're telling this happens in our cloned code. Just use a random original instruction. And when we see the difference with the next block, we're also doing a run trace, but we are making the trace in a cloned instruction. And remember, the tool will introduce a random number generator. The traced string will be a bar here and a dash at this point. Okay, so now let's become real. So we'll open the console. We are already in the right directory of the console. I'm running a script here, but you will. What really should happen is you need to modify the source code for the markers. You need to compile the application. Then you do the protection, which reads the object files. When you do the protection, when you're done, you have to link the application. And lastly, I need to run the application. Now I'm doing everything except running the application in one little script. ms build my. And we are done.
Wow.
In this case, we not only compiled the application, we also run the protection of the application and linked the application. So what is left is running the application so you see how the protection did. The application is named protected.exe. It ran. And what you see is that both sides of this clone have been executed. You could go and analyze the quality of the random number generator here. That quality is very important for most of the places where it's used, but in this particular case, to add some random noise, it wouldn't actually matter. But anyway, you see, the last part of my program is that my program just keeps writing dots until it is interrupted. I do this in my test programs so that I have time to start running a debugger and see whether I can hack the application or not. So here I have the Oli debugger. So I'm starting a debugger. I need to double click a little bit better so it's loaded. It got loaded. But did you see what happened in the background? We don't need the debugger anymore. The application noticed that Oli debugger was started, and I forgot to remove some of the test output, which is programmed in the application. So please, users, don't do that. But what we see is that we have a watchdog, and that we named the watchdog Fido, and that it did bite. So the application is interrupted before the debugger can get any information out of it. So that basically concludes the demo. I can add some of the important things we have, like the extension mechanism and special things. So we do have special means to allow us to debug a protected application, but don't debug protected applications, really. Debug the application before you do the protection, and just make a last debugging effort to see that the protection did not break it. Of course, it will never break it, because to break it, there would be a bug in my code. So we're not expecting this to happen, but it's maybe not as thoroughly protected as a compiler which is used by everybody, so it needs that debugging, or it needs it at least for me.
Wonderful. Well, thank you so much for showing this to me. I really appreciate it.
You're very welcome. In fact, I'm so glad I was able to make a real demo.
I'm glad you're able to show it to me. Well, that's all the time that we have for today, so be sure to tune in next time for another episode of Access Point. Also, make sure to subscribe to our YouTube, Twitter, and Facebook so you don't miss out on any of the latest cybersecurity news. This episode is brought to you by Pen Tester Academy, the leader in online cybersecurity education. Join over 10,000 professionals from 90 countries to learn security online. Also brought to you by Hacker Arsenal, artillery for cyber warriors. Visit us on hackerarsenal.com to check out our latest attack defense gadgets. Thanks for watching, and we'll see you next time.